Okay, let's continue with question number 3 of tutorial number 3. I've decided not to ask such questions in the exam, by the way, Poisson approximation of binomial distribution. So this topic I won't ask in the exam. And the reason is that I want you guys to focus on the previous question, question number 1 and 2, because it's very important to know about binomial and Poisson and how to distinguish between them. Approximation is another level when we don't have information about one of them. And I also told you that when the sample size is big enough and the probability is very small, then you can use this approximation. In the lecture, I explained about it, and I wanted to give you one example. At least for this semester, let's not to ask it in the exam, but I'm going to show you anyway how you can deal with such examples. So it is indicated that 2 out of each 1,000 patients in a hospital in South Korea has the chance to be infected by coronavirus. So again, this question, I have designed it last year when it was at the beginning of COVID. And if you remember, after China, it was a big deal in South Korea how to deal with coronavirus, but this is worldwide these days and we are all suffering from it. Anyway, so use Poisson approximation of binomial distribution to calculate the probability of 3 patients among 10,000 patients in the hospitals of South Korea to be infected by this virus. Okay, so here we should know how to find lambda. If you find that, then it's easy to use the formula and find the answer, because the question is, what is the probability of 3 patients? So the only thing left to do is to know which distribution we are talking about and how to calculate the parameters and then use the formula. So I want to use Poisson approximation of binomial distribution. So this is the distribution that I'm looking for. But the question you should ask yourself, how to calculate lambda? So here the question is asking you, what's the probability of 3 patients among 10,000? So if I change 10,000 to 1,000, then this one would be standard format, right? So again, vice versa. If I want to convert from 2 out of 1,000 to 10,000, what should I do? So in this case, lambda is not equal to 2 because the population has changed. I mean the size of the population. So in that case, when this is 1,000 and we change it to 10,000, 2 should be multiplied by 10, right? Because 1,000 was multiplied by 10. In a simple ratio, as all of you are familiar with, 2 over 1,000 is equal to, what's lambda here? If the population now is, the population size is 10,000. So lambda should be equal to 20, okay? Now, that's the way we could understand from this simple ratio. So when you want to calculate it from here, what's the probability of x equal to 3? You should know that you should take a look at Poisson distribution with the parameter 20, not 2, okay? So you know the formula. So very easily, by considering what is lambda, what is x, you can insert it inside the Poisson formula and then find the final answer based on that. And if you prefer also, you can change it from here to read it from the table. Also, let me explain about it briefly. So whenever you want to change the format of equality, you can do it like this. This is less than or equal 3 minus probability of x less than equal to, and you find the final answer. So you should be careful when you want to read it from the table Now we are talking about lambda equal to 20, okay? And we should have this calculation. Doesn't matter whether we needed the formula or not, because for Poisson distribution, the table which is given to you is based on these parameters. Okay, in another video, I will show you and we will practice how to read from binomial and Poisson table in detail. So whenever we have, for example, probability of, let's show it here. When you have probability of x less than equal 2, for example, then if I know the parameters of my binomial distribution, so P and N, and as I said in some book, they show N and P, the components doesn't matter. So if I have information about P and N, then based on that table of binomial, I can read the final answer for these. Also the same for Poisson distribution. If, for example, we have less than equal 2, and I have information about lambda, then by having this information, I can answer this question. So in the previous questions, you saw that I showed you the last format for the table, and I said you can read it from the table. Now we want to practice with that in the next video.